All right, so let's look at question 60. Let's agree to call a number nice if it is not divisible by either 4 or 9. Which of these statements is always true? So when we do a problem like this, I recommend looking for counterexamples for different rules, because it's really easy to prove something isn't true all the time, and it's really hard to prove that something is true all the time. So if we look at A, it says if a nice number is multiplied by 5, then the result is nice. Let's try two different nice numbers. 10 is a nice number. It's not divisible by 4 or 9. 10 times 5 is 50. That is also a nice number. What about 12? Oh, sorry, 12 is not a nice number because it is divisible by 4. What about 13? If I do 13 times 5, I get 65. And that is also a nice number because it is not divisible by 4 or 9. So we're not sure about A. All right, if 5 is added to a nice number, the result is nice. Huh. Let's think of a non-nice number. So a non-nice number would be 18, and 18 is equal to 13 plus 5. 13 is definitely also a nice number. So I added 5 to a nice number just now, and I did not get a nice number. So we know that this is not always true. The sum of two nice numbers is nice. Well, let's think once more. 18, once more, like we said, is not a nice number. It is divisible by 9. But let's see. Can I use two nice numbers to make that? 15 is not divisible by 4 or 9. 3 is not divisible by 4 or 9. You can add two nice numbers together and not get a nice number. And actually, the example we used over here for B also shows that. All right. Then it says the product of two nice numbers is also nice. So let's see. If I have, for instance, 3, which is a nice number, and I multiply it, I'm going to keep working with 18. Actually, I'm going to keep playing around with 18 because that's not a nice number. 3 times 6, those are both nice numbers. Neither of those is divisible by 4 or 9. But when I multiply them together, I did get a not nice number. I got 18, and that is divisible by 9. And then lastly, it says if a nice number is multiplied by 3, the result is nice. Once more, the example we used in E shows that that's not true because 3 times 6 gives me 18. 6 is a nice number. It got multiplied by 3. It gave you a not nice number. So we know that the answer has to be A. I realize I forgot to do number 59. Robert has been on the road for 1 hour and 50 minutes. He has been traveling at a constant rate. So far, he's traveled 1/6 of the way to his destination. If he continues at the same rate, he will arrive at his destination at 3:30. At what time did Robert start? Well, so 1 hour and 50 minutes is 110 minutes because it's 1 hour, 60 minutes plus 50 minutes. That's only 1/6 of the way. So he has to do that same exact thing 5 more times. If you take 110, because each of these portions of his trip are 110 minutes, and you multiply it by 6, you're going to get 660. Let's turn 660 back into hours and minutes because working with just minutes is a little tedious. 660 divided by 60, that gives us 11 because you can cross out the zeros, and then you have 66 divided by 6, which is 11. So this is 11 hours. There's two different ways to do this, but I think the easiest way is just to think, well, what is 12 hours before 3:30 p.m.? Well, that's 3:30 a.m., but we're not going to go all the way back there. we have to only go 11 hours back. So 1 hour after that is 4:30 a.m. You can also just count back on your fingers from 3:30 p.m. what would be 11 hours before. It says numbers v, w, x, y, and z are placed on the number line as shown below. Which expression has the greatest numerical value? There's a few different ways to do this. We already see that z is the biggest thing here. So we have two different expressions with z minus w and y plus z. Look at this, y plus z would be this value plus this value, so that might be kind of big. Let's write what that is, that's 2. And then z minus w, that's 1.5 minus negative 1.75, which is what w is. This minus minus turns into a plus. That already looks like it might be bigger than some of the other values here, just because the z was involved. All right. Then let's see some of the other options. You have x times y. X is negative, y is positive. When you multiply that, you're going to get a negative number. E is not a negative number. 3.25 is not a negative number. You already know it's not a. You don't have to play around with that. Then you have v divided by x. This time you do have two negative numbers being divided by one another. And x looks x looks kind of close to 0.00. So it could be that, let's see, negative 3, which is what v is, divided by, maybe we could estimate negative 1/10. Remember our rules for dividing by fractions. You have negative 3, you keep that the same, you change this upside down, and you turn this to 10 over 1. And sorry, this negative would go away as well, because when you divide two negatives, you get a positive. So this is 3 times 10 over 1, which is 30. That's actually pretty big. That's actually pretty big. And then lastly, you have v squared, which is negative 3 times negative 3. That would give you 9. We didn't have to try out all the choices, but we did see pretty quickly that it was B. Says for 62 that a magic square is a square where the sum of the entries in any row or diagonal is the same. For the magic square below, what is the value of A? So we know a few things. We know that these plus, and these have the same value. We know this and this have the same value. And we know this and this have the same value. There's a few different ways to go at this. I think that oddly enough, the easiest way is just to do the algebra. So pick two sides that don't have an A. So I'm going to pick this one, 2x plus 10 and x plus 7. So I'm going to say 2x plus 10 equals x plus 7. Always think of your equations like a balance, And if you take something away from one side, you have to take it away from the other side as well. I have 2 x's here on this side, and I have 1 x here. So if I take this x away from this side, I have to take 1 x away from this side as well. I'm left with 1x over here plus 10 equals 7. Then we can do the same thing with the 10. We'll take it away from this side, which means we have to take it away from this side as well. And we'll get that x equals -3. But remember, we're not done yet. We know that a is not equal to x. A is actually equal to 2x plus 10 or 3x plus 3 or x plus 7. Actually, it's equal to all of those. So we're just going to pick the easiest one, the one that looks the simplest to work with. X plus 7 looks to me like the simplest to work with. But instead of having this x, I'm going to substitute the -3. So I'll have -3 plus 7. And together, if we add those, we get 4. So one of the quickest ways to add negatives and positives is to think about them moving in different directions on the number line. So you're kind of subtracting them, kind of. And 7 minus 3 is 4. And it takes the positive sign because 7 is pulling harder than the -3. Question 63. Mickey prepared 2 gallons of a beverage that contains tea and lemonade in the ratio of tea to lemonade 3 to 1. Let's draw a little picture. This is our tea. Our tea is 3 parts of this, but only 1 part of this is lemonade. I'm just going to write an L there for lemonade. It looks like there's 4 parts in total. If Mickey then added 1/2 gallon to the mixture, what was the ratio of tea to lemonade in the new mixture? So let's find out how many gallons of each there are in the whole mixture. So this is tea and lemonade together, and together that's 2 gallons. Well, if this is 2 gallons, then to find what's in each of these, we have to do 2 divided by 4. 2 divided by 4, or 2/4, is 1/2. So this is 1/2, this is 1/2, this is 1/2, and this is 1/2. Mickey added 1/2 gallon of lemonade to the mixture. So let's go into our red. And we know that there's yet another 1/2 of lemonade. What's the new ratio? Well, now I see 2 things of lemonade and 3 things of tea. So the ratio of tea to lemonade would be 3 to 2. And I'm going to stop this video now and do the next one after pausing this.